Team 2210, and we will be performing the MEMS magnetometer fluxgate project from General Dynamic Electric Boat. Project overview. A MEMS magnetometer is a device used to measure the direction of magnetism and strength of the magnetic field. The MEMS portion of this project is a microelectrical mechanical system, and this is developed so we can reduce the size and cost and also integrate it into an IC chip. Fluxgate magnetometer principles. A fluxgate consists of a small toroidal core with what we call a drive coil wrapped around it. This drive coil is excited by a square wave, and this square wave in the positive half cycle will magnetically saturate our toroidal core in the counterclockwise direction, and the negative half cycle will magnetically saturate the core in the clockwise direction. By looking at just the positive half cycle, we can see that the right-hand side of the core will saturate in the up direction, while the left-hand side of the core saturates in the down direction. When no external magnetic field is applied, both sides of the core will saturate simultaneously, leaving no flux within the system. However, when you introduce a magnetic field, say in the positive up direction, then the right-hand side will now saturate slightly before the left-hand side, and this will now leave a non-zero net flux within the system. By wrapping an entire sense coil around the system, we can use that induced flux to induce a current within this coil that is going to be proportional in magnitude to the external magnetic field applied.
The core chosen for the fluxgate is very important as it determines how many turns we would need on the core. The materials we chose was 3E12 and T46. Higher permeability was desired, but the quote was too expensive, but these should be sufficient. The saturation flux densities for these was for the 3E12, 470 millitesla, and the T46, 400 millitesla. Two different sizes were received, so that way we could be able to determine how many cores we need or how many turns we would need for the cores. For the design, the saturation flux density needs to be 10 to 100 times saturation flux density, so we chose 50 times the flux density to be in the middle, and we came out to 669 turns for 29 gauge wire, and then 118 turns for 29 gauge wire on a small core. Sense coil is to be 2 times the drive coil, so just do the previous turns multiplied by 2. Microcontrollers used in this project, we use the Arduino XIAO. The Arduino is in charge of serial communications to Simulink. The ADC is used to have the sensor output be digitalized. 1 millisecond timer is used for communication and sampling. And we have a signal generator to produce the -7 and 7 volts for the drive circuit.
We will need to implement a sensing circuit for this project in order to amplify and clean the current in the sense coil. This sensing circuit consists of 3 parts: the amplification stage, the bandpass filter stage, which is at 1000 Hz, and the lock-in amplifier, which will further reduce the amount of noise within the system. We will also be implementing a serial communication link between the Arduino XIAO and Simulink, and so far we are having some issues with this, but we will resolve them shortly.
Besides the microcontroller and the tool that we're using for signal processing, MATLAB, 4 main circuits are needed to operate a fluxgate: a voltage divider, a drive coil amplitude converter, core drivers, and sensing coil preamplifier. The voltage divider can split the input voltage to a half positive and a half negative voltages with a common ground in between. The square wave amplitude converter can convert the 0 to 3.5 volt square wave coming from the microcontroller to square wave with an amplitude proportional to the input voltage. There are 2 square waves coming from the microcontroller and they're shifted 180 degrees apart. The core driver can be controlled by the square wave amplitude converter. This core driver can provide enough current to drive the cores into saturation 100 times. Another important component is the small signal preamplifier, and this preamplifier can amplify the signal around 10,000 times. It can also filter some of the noise before sending the signal to the microcontroller. This small clip shows the operation of one of our prototypes.